Can you guys hear me fine?
Yes.
Okay. Thank you, Kosuke, for a nice introduction. Good morning, everyone. I hope everyone is doing fine today. Had a good breakfast. I'm Pramod Rana, and I'm going to speak about how to have visibility and security of CI/CD ecosystem. Before I start, let's make a deal, which I do with most of my conferences, that I want it to be an interactive session. By no means I claim to be an expert or anything like on that front. It just I'm sharing my pain on a day-to-day basis as an AppSec professional we face in our organization, and I have faced in previous organization. So if you have any questions, any opinion, any thought process, please feel free to stop me then and there only, and let's make it an interactive session, and everybody learn from each other in that way. We have a deal?
Yes.
Okay, cool, thanks. So a bit about me, I am leading application security assurance function in Netscope. I have been in industry for more than 16 years now, and I started as an offensive security engineer. Later on moved into the application security space. I have three open source projects, Omniscient View Prioritizer and CICDGuard, which I speak at different conferences, including Black Hat, DevCon, NullCon, so and so forth. I'm from Pune, India, and I am very happy to be here. I also lead our OS Pune chapter. For those who are not aware, OS is an open application security project, which is a de facto when it comes to the application security standard. And I did my OCP 10 years back. So before we start, how many of us here working in application slash product security domain slash DevSecOps? Okay. How many of us are developer here? Okay. Okay. How many of us deal with CI/CD on a daily basis? Alrighty. So the context is when CI/CD came into the market, into the industry, like 5-8 years back. The fundamental of the security changed primarily because how the software was getting developed drastically changed with the introduction of CI/CD. Nowadays, if you go to, let's say, your mobile application and you open the Play Store, you will see updates to multiple applications in your mobile on a daily basis. What it means is that nobody is waiting now for even weeks to have the updates or the new introduction of the features into the product. It's happening on a continuous basis, because of which there was a new I'll say domain of the introduction of the security introduction into the industry, which was called security in CI/CD. What it meant was that we are having an integration of the security controls across SDLC process. Over the period of time, fast forward today, what's happening is that those CI/CD controls having more and more power to them. What it means is that they have access to more and more information, and the introduction and the access to the information in terms of what it means is that those CI/CD platforms controls becomes more and more critical to the organization. So this talk is about securing those building blocks. Whatever is making your CI/CD workflow, it will vary as per the organization, it will vary as per the team, it will vary as per the product. But overall, whatever platforms, whatever technologies is building your overall CI/CD flow, those platforms, those controls has to be secure. So if you look at the diagram here, I have just jotted down a couple of these. Like GitHub is obviously like 90% of the organization must be using. Now they have an introduction of the, not now, like few years back they had introduction of the GitHub Actions, which is a DevOps platform for that. We have Spinnaker, we have GitLab, we have JFrog, we have Drone, so on and so forth. So it's about securing those building blocks, which is security of CI/CD. Like in any ecosystem in nature, it's similar to the CI/CD ecosystem. If one block, one component is compromised, it always has a cascading effects on the overall process. That's why the software supply chain security came into the market. So a part of it is that if one of the technologies within your CI/CD ecosystem is getting compromised, it will have impact on the overall software delivery process and eventually the data of your customer. The third part, which connects back to my first point, is the visibility part, which is in today's time it's easy to spin up easy to bootstrap the technology, because most software providers make it extremely easy for user to boot it up. Because of that, what happens with the security is that we are not aware what we have within our organization, which is what the visibility part of is. For example, in our organization, if in most organization, if you want to, let's say, boot up a Jenkins server, we just do couple of deployments. Now with the code deployment, it becomes extremely easy. But with that, the visibility part becomes the problem for the security. These are the two problems I'm trying to address. The visibility part, to understand what all different platforms you have within your organization, within your environment, and how to approach the security of it. Okay, we good? With that, I built a open source platform. I call it CICDGuard, which does a couple of things. The first thing is, it represents each different modules of the overall CI/CD platforms into the graph forms. It breaks down all the different technologies to the granular level as much as possible, and represents each information, each metadata in form of the node. And it identifies the security misconfiguration in the implementation of the integrated platforms. The third thing is, it identifies the relationship between the different platforms into the environment. Let me give you an example. Let's say your overall CI/CD workflow looks something like this. You have a GitHub as your SCM, and then you have Jenkins, which is integrated with the GitHub, which triggers a job with the pull request into a particular repositories. That job eventually builds your software using the repository you are able to provide with the GitHub, and then it builds it and it deploys into the, let's say, a JFrog artifactory as a artifact into the system. A very simple process. You have three controls. You have three platforms. You have three technologies. First is GitHub as your SCM. You have Jenkins as your DevOps platform, and then you have JFrog Artifactory as your artifact solution. If a security issue is introduced into the GitHub process in this overall flow, eventually it's going to impact the artifact which is stored in the artifactory. As of today, if you look at it individually, it's very difficult to do that mapping. So with the CICDGuard, I have tried to find that relationship, that from the source to sink, how it eventually is leading up to your software process and the softwares you are deploying in your customer environment, or you are providing as a service to your customers. I have given some couple of examples. The one I spoke was the particular repository change triggers a Jenkins job, or we have the different version of GitHub action. This is another example. So for example, if you are using publicly available GitHub actions, which is eventually a let's say add-on into the existing GitHub action workflow, most organizations, what they do is that they make a process where if there is an introduction of a publicly available add-on into your environment, they do a security review of that and make sure that it's vetted with the fundamental security checks. For example, who is managing it, how well it is maintained, when was the last security updates of those. It just doesn't apply to GitHub action, it applies to almost everything which works as an add-on into the Jenkins. So for example, as your platform. For example, in Jenkins you have plugins. Now let's say as a security professional, you approved one external add-on into your environment, but those external add-ons will keep updating. How do you make sure that you have the inventory of all the third-party add-ons you have in your environment? If you are searching to, let's say, a Jenkins platform, how do you make sure that the plugins used in your Jenkins environment is matching with the inventory what has been approved by the security already? Or how do you verify that external workflows introduced in the GitHub action is verified by the security team in your organization or whatever security process you have. Okay, before I move forward, any question?
Can we turn off that auto update of the add-on or have a change control process so that we don't get change unaware?
Yes, we can do that. But with that, the assumption is that the only way of introducing a new technology in your environment is through the change process, which practically speaking, it may happen for a very big and stabilized organization, but for many organizations, that doesn't get applied. It may say as the process, but that's where it's coming, that the governance piece of it. As a process, we are saying that when you want to introduce, this is the process. But how do you make sure that that process is followed? Or there is no other way of introducing other than that process? Any other question? Guys, come on, we made a deal, right? This might be the most quiet and very disciplined audience I had in a very, very long time. Okay. So this is what the architecture of the CI/CD looks like. There are four major pieces to that. First is the scan engine, which actually does the scanning. So what I have done is, like I said at the start, the complexity of the DevOps platform or CI/CD platforms is too much to handle in today's time. Almost we have 100, maybe more than that, platforms used by different organizations. So it did not make sense to me to make a single solution supporting all. So what I did is I broke it down in terms of the technology and make it as modular as possible, in the sense that even if you are using just one single technology, you should be able to use it, irrespective of whether you are using others or not. So what I have done is I have made different scanners for different technologies. Now you may ask why GitHub and GitHub Actions are different scanners. In my opinion, though they belong to same organization, they have been provided by the same organization, but their fundamental purpose is very different. GitHub is supposed to be a SCM, a source code management, where the GitHub Action is a full-fledged DevOps platform. And I'm breaking down in terms of the purpose of the technology, what they were supposed to do. Obviously, when we look at the configuration or misconfiguration of those technologies, it will be very different from approach perspective. So that's why those differences are there. So as of today, I have made it for 4. I'm working on 5. I should be able to push it this week. And then others are working. So what happens with this scan is, these are bunch of Python scripts depending on the technology. Even if you want to use just that script, that individual script, you can use it and consume the output. You don't have to use rest of it. You can use it and get it. What happens with the scan engine is, let's say you scanned your Jenkins environment first and then you scanned your GitHub environment second. With the analysis engine, what is going to happen is it's going to identify the relationship between those two nodes as long as you scanned both of them and put the data into the same database. For the graph theory, I am using the Neo4j database. So what happens is, you scanned it, there are couple of ways you can consume the output. The first is that it will just simply print into the command line. You can copy paste it there from, use it, not very ideal. Second is, you can create it in the form of the JSON and then feed it back to your other solution which you may be using as per your environment. That's second option. Third option is, while it's happening, you put that data into the Neo4j database. So first you scan Jenkins, all the scan results, all the information, and when it does the scanning, it just doesn't look for the security issues. Remember, visibility is the first challenge. What it's trying to do is read the environment first, irrespective of the security issues. So what it will do is, it will read all the users, all the groups, all the plugins, all the jobs, all the builds in case of Jenkins, the platform what are the security controls implemented within the Jenkins controls, so on and so forth. It will read everything and put everything into the Neo4j database. Next time if you run GitHub, again it will do everything. It will again read all the users, all the groups, all the repositories, all the settings within the repositories, what are the security settings you have implemented, so on and so forth. Again put it into the Neo4j database. Now analysis engine will go back to the Neo4j database, find what all different technologies it has identified, and then find the relationship between those technologies. And second feature of that is, while it is doing that analysis, it will look for the security issues within those target environments. So first, component scan engine, which is nothing but a bunch of Python script as per the technology. Second is the analysis engine, whose job is to identify the relationship between the technologies and the security issues. Third component is obviously database. There are a couple, not database, output. First is Neo4j, you can store it, use it later. You can use Neo4j console if you want, or whatever way you want to consume it. JSON is there, terminal print is there. And then there is a small little web UI to view all the data. I'm personally not a front-end developer. I'm focusing primarily on the back-end piece. That's why I said, if the data is into the Neo4j, Neo4j has already made a very good web console around it, so you can use it there also. And then there is a last piece. In order to do all the scanning, you need some form of authentication. There is no way to do the scanning other than that. So for all the scanning, we need a read-only user, but having access to all the resources. What it means is that if it's a GitHub, all the repository, that user or that service account should be able to read all the resources within the target environment. Let's say you configured an account which don't have, it will still go and do the scan with whatever access it has. There are a couple of ways you can do the scanning. I personally prefer environmental variables so that you don't print it out every time. You can put it into the command line also. You can store it in a configuration files. It will automatically run it if you want to configure it, so on and so forth. Okay, so just a recap: scan engine does the analysis, or does the scanning. Analysis engine does the scanning, analysis, and we have the output in different forms available, and we need some form of authentication to do those scanning. Any question before I move forward? No, we're good? All right. Next I have the demo. So as you can see, if you go to the GitHub, there is a scripts folder. Under that, like I said, as of today, I have four scripts. So this is what it looks like. You have literally like JFrog scanner, GitHub scanner. So as for the demo purposes, what I've done is I have configured the credentials and the target environment in form of the environmental variables. If first thing it's going to do, it's going to fetch it from the command line. If it's not available, it's going to reach to the environmental variable. If it's not available even there, it's going to reach the command line, configuration file. Okay. So what happens is, as of today, I have for the demo purposes, I have mask the actual name of the organization in the big brackets. When you will actually run it, you will see your organization name. In case of private repository, you are going to see your username as an organization name, and then the repo name will be there, obviously. It will keep fetching whenever there is a green node. So how I have done the error handling is, if you are scanning even a medium-sized platform, in most organizations, the data is huge, and I have tried my best to capture all the exceptions, but still there are some exceptions for the unknown scenarios I haven't encountered yet. How the exception handling will happen in this scanning phase is, even if it catches an exception, it will continue the scanning. It will just skip that piece. So what will happen is, for example, you are scanning a repository and let's say a repository name is not aligning with what I have assumed or anticipated here. It's going to skip that particular repository, but it will continue scanning. As you can see, I have already, so yellow are the exceptions and green is the successful run. It will keep fetching, it will keep scanning. I have intentionally kept it as real time so that you guys understand how much time it actually takes. It's a reasonable sized, this is how the output looks like. It's a reasonable sized target environment. Most production, so to say, the actual environment will be slightly bigger than that. So it might take more time than this. So what happened as of today in this scan is it scanned one technologies. It printed it into the command line and it put all the data into the Neo4j. Now, what I'm doing is I'm scanning a second environment. What it's going to do is it's going to do the same process, again environmental variables, and put all the data into the Neo4j. As long as data is into the Neo4j, in the back end, I ran the analysis engine. So whenever this scan is putting the data into the Neo4j database, the analysis engine is picking up the data from the previous scans as well and trying to identify the relationships. So again, it takes time. It's a reasonable sized or the target environment, so it will take time. Like I said, I have kept it real time just to demonstrate how actual time it takes. So it's processing jobs, it's processing batches, it's processing builds, it's processing last and successful build, so on and so forth. Then it will process the user details of that target environment, a user node created. When you will actually run it, you will see the user name like node Pramod Rana created successfully, node user Pramod or whatever name. Now it's fetching all the groups to identify which groups have the admin privileges or the privileges which they normally should not have, or the controlled groups, like you might have an additional privileges assigned to it. So that's what it is doing in the backend. Yep. Same thing happened, printed output in it, not a very good looking, but printed output in the terminals and put the data into the database. Now this is what I scanned, I think four or five environments with it. I scanned JFrog Artifactory, I scanned Jenkins, I scanned GitHub, and I scanned GitHub Actions. For the demo, I just showed for the two. Even if you scan this, I'll say middle-sized target environments, and I just scanned 4 technologies, data becomes quite messy. Like I said, because I'm trying to go as granular as possible in order to know everything. What is of interest for security or DevOps platform will differ as per their goals and objective. So I have made a very basic filtering. You can use the Neo4j console for that as well. Red represents a vulnerable node. In the node, so node will represent a certain feature of the product or certain functionality of the feature. Edges between the nodes will represent a relationship. So again, give you an example on the perspective of the Jenkins. A build and job, they both are nodes. Build is a node, job is a node. The relationship between those are when it was last ran. So jobs triggered a build. That's a relationship. In GitHub, user is a node, repository is a node. User has access to repository is a relationship, is an edge. Again, a user is a node, a group is a node in context of, let's say GitHub. User is part of that group is a relationship or an edge between them. So in that way, you will have number of nodes and number of relationship between all those nodes. A job got triggered because it was configured to scan to initiate with a particular repository change. That is a relationship across technologies. So a GitHub repository is related to the node into the Jenkins, or a GitHub action was triggered with a, let's say, a change into a particular branch of the repository. That represents a relationship. Now here again the branch will be a node. So you will have a cross relationship between those. So red nodes, all red nodes represents that they have some security issues in between, in affected area. So you can make a filter. It's an AND filter. When you select two nodes, it represents AND. Now here I want to show a specific, for this demo I want to show a specific, the relationship across the technology, which I think we are missing as an industry itself. We don't have a good way to identify the relationship across different technologies. So as you can see, this color, it represents Jenkins. I even don't know what's the name of this color. And the black node represents a GitHub. So since this node, this red node, had a security issue, which is a GitHub user, this user did not have the MFA enabled, and this user had a right access to a particular GitHub repository, and this GitHub repository is responsible for triggering a build, which I know is responsible for building a binary which we deploy in our customer environment. So just to give you perspective, a user which don't have, now it will connect back to the point which he raised, like the process perspective. MFA, as per the process, we says that MFA has to be enabled for the GitHub users, but this user did not have, that's why it's red. Then that user has right access to the repository. Whatever changes he does or he may not do, it will reflect to the GitHub build, and then eventually Jenkins build, and then eventually it will trigger to the binaries which users are deploying into their customer environment. So this is one environment. As you can see, this is a Jenkins build which represents this, and then there is a GitHub node which is connected to this. So there were two relationships we were able to identify with this across technologies. So same thing here. This user has the right access to two repositories. It actually has right access to other repositories as well. And then if you access it via the Neo4j console, you can make a query on the basis of the on the field as well. You can search the edges which has the metadata as write access only, so that you know all the users which don't have the MFA enabled and have write accesses or maybe admin accesses to different repositories. So that's how it helps in terms of the visibility part to fetch everything, which is the main thing. And the second thing is obviously identifying the security issues associated with the target technologies, and then find the relationship across those technologies to find the security issues which may impact in a different technologies, starting from the source code to in your target environment. And more integration and the scanning this CICDGuard will do, more and more the complex relationship will grow, and more inter-technology issues we will be able to identify. Now imagine a scenario, we integrated it with our infrastructure environments. Let's say you are using a cloud environment, and then that environment is also scanned with this. Eventually it will identify, for example, you have your client version, you have your binary version, let's say x.y, that was triggered by a user who was not supposed to have access to that repository. And then you identify in your cloud environment which container is running the binary version x.y in your environment, so that you identify the runtime awareness on that front as well. So that was the demo on our side, and this is what I had from my side today. If there are any more questions, I'll be more than happy to take it. If there are any suggestions, any feedback, that also is equally welcome. I appreciate everyone coming here. Thank you so much, and it's been a pleasure talking to you. Thank you, everyone. Yep.
Hi. It was a good, but is it possible to see like when you click the red button, like square, that what is the issue? Because maybe you showed I missed it, but I would like to see like what is the like security issue list of like when I click the red button.
So what I'm doing on that front is, in this demo it wasn't there. You didn't miss it.
Okay.
I did not show it. So what I'm doing right now is that when you click it, a panel will be displayed which will show all the information.
Okay.
Yeah. So data is there. It's like I said, I'm not a front-end developer, so I was struggling to show it in the front-end itself. Yeah.
Thank you.
How do you model the relationship between components? As you mentioned, it can be complicated.
It is. So how I approach is, my thought process was to break down the technology first as much as possible. Like on the for the repositories, it's everybody use it, right? For the repository, I just didn't say that repository is a node. I say that branch itself is a node. All the users are node. In the repositories, all the commit is a node. Whatever changes you are having, all the metadata eventually becomes node. And then try to identify how a typical DevOps workflow will look like. So if in context of the repositories, how it works, like that a user creates a branch, let's say for a specific feature, he or she makes commits, put it there, and then there is a pull request to merge that. Again, pull request is also a metadata. So I just naturally, what was the workflow? On the basis of that, I created the relationships. Possibility is that there might be some relationships which might not be there. For example, a pull request, as of today, for example, I don't know how a pull request will connect to let's say a group. So how it's working, a pull request will connect to a user, a pull request will connect to the commits, a pull request will connect to two branches, then the user will be connected to the group. But a pull request is not directly connected to the group. That's how the building is working. That's the thought process.
So since this is open source, if people, organizations adopt this, they can model their relationship if they need to.
Obviously,
right?
yeah.
Because the use case can be slightly different depending on the organization.
Yeah. For example, in this case, I'm in the repo discussion only. So like some organization have very strict rule that their branches has to align with certain nomenclature. Like some make on the basis of the user, some make on the basis of features, some make on the basis of, let's say, Jira ticketing. So depending on that, their thing might change. Like for example, main branch can be of different name or different purposes. Yeah.
Thanks.
Yep, sure.
Thank you for the talk. Was there anything unexpected, any unexpected issues you ran into while developing the tool?
I have no idea. So the finding the relationship was the most tricky part, because I'm a security professional. I do coding as a hobby, but I wasn't fully, let's say, aware of how a process will look like from a developer and DevOps perspective. So because of that, I needed to understand the overall DevOps flow, and still it's very complicated because of the fact that technologies is too evolving. For example, if you look at the GitHub action, it can do literally everything a DevOps solutions can do. It depends on how organization has implemented. So to understand those variations, like how the organization is implementing it. For example, even in a single organization, different product teams using it in a different way of storing it. For example, in case of secrets, some prefer to store it on the organization level, some prefer to store it on the repo level, and then some store it on the basis of the user level, which is not recommended. So understanding those variations was the most difficult part, and because of that, it will connect back to that exception point. I know as a developer of this that I cannot catch all the exceptions. That's why I have kept it. I did not want to print it, but it will be in the logs. So if anyone can troubleshoot it, it can work that way. So there will be some exceptions where it will not be able to capture all the nodes and the relationship of all the technologies. It's as per my data, but there might be some other variations. Okay, thank you. Any, yep.
Thank you so much. It was a very informative session. So, like, my question is, like, in the flow, you said that like scan engine and analysis engine, they both do scanning. So, what are the like crucial difference between their scanning? So, scan engine only scan the individual repository, or analysis engine like share the data with whole repository and scan on that.
No. Scan engine job is to identify what all is there. For example, if I enter in this room and I'm the scan engine, I'll just say who all is sitting here. That's that. It's just data collector, you can say. And then analysis engine is which does the analysis. For example, how many people are developers, how many people are application security professionals, let's say. Those relationships, those understanding will be done by the analysis engine. Make sense?
Yeah, thank you.